Recording in progress. Hi, students. In this lecture, I am going to discuss how to calculate center of mass for a circular arc, semicircular plate, hemispherical shell, solid sphere, solid cone, and hollow cone. In all these things, distribution of mass is continuous. Okay. Let us see calculation part for first one, circular arc. Let's see first one how to start. Let us say this is now a part of a circle, so calling as R. Calling as R. Let us say this is a part of a circle of radius R. Radius is R. And this makes an angle theta at center of curvature. So when you join these two ends, they meet at center of curvature. And let us take that angle as it is a theta. So we have taken radius is R, and that makes angle theta. Now for this we have to focus center of mass location. Okay. See here by symmetry what we can say is center of mass will be on the line of symmetry. So I am taking one line here symmetrically. Let us call this as y-axis. So center of mass will be on the line of symmetry. Okay. See how we take elements. Let us consider at some angle alpha, take a small change d theta. So I am taking here from the symmetry line angle theta, and this is now small change d theta. Now this will be the arc length, which is r d theta. To avoid confusion, since we have taken total angle is theta, let us take this is alpha. This is alpha. Okay. Then this is d alpha. Then this becomes r d alpha, length of that small element. Now this is just like a point mass because this d alpha is very small. D alpha is very small. Therefore, this is just like a point mass. For that point mass, see what is y coordinate. This is now its y coordinate, right? This one. So it is equal to how much? R cos alpha. Its y coordinate is r cos alpha. Now see the calculation part. YCM is equal to integration of y dm upon integration of dm. Okay. So we are taking for this point mass, y coordinate is r cos alpha. So writing here in the place of y, it is r cos alpha. Okay. Next, coming to dm. Coming to dm, this is a wire, right? So since it is now linear, we have to take dm is dm equal to lambda into the corresponding length r into d alpha. Okay. So dm equal to lambda into r into d alpha. So I am writing here in the place of dm lambda r d alpha. So observe carefully how we are taking the calculation part, means how we are taking first elements. This is not a point mass, right? So we should take one element. So we have taken angle alpha, small change d alpha, that length is r d alpha. For that small part mass will be lambda into r d alpha. And for that point mass, y coordinate is r cos alpha, right? So y dm upon integration of dm lambda r d alpha. Okay. Right. Now see what we can do. Calculation part. Remember, like this, we have to take all elements from alpha equal to theta by 2. That is a clockwise. Again, theta by 2 anti-clockwise. So you should focus very carefully on limits. Theta by 2 anti-clockwise, theta by 2 clockwise. If you take clockwise positive, anti-clockwise is negative. It is a completely our choice. So generally we are taking anti-clockwise as positive. Then limits are minus theta by 2 to theta by 2. Same thing here also. And you can see here constants lambda r, both are constants. So we can cancel. The remaining is now r cos alpha d alpha. R is a constant, take outside. R is a constant, taking outside. The remaining is now integration of cos alpha d alpha upon integration of d alpha. Okay. Now take integration of cos alpha d alpha, that is sine alpha, right? That is equal to, I am taking here r outside. Integration of cos alpha d alpha, that is sine alpha upon alpha. Now substitute limits. R sine theta by 2 minus, I will write here, sine theta by 2 minus sine minus theta by 2 upon theta by 2 minus theta by 2. Okay. So here major part is taking elements and corresponding limits. This becomes now sine theta by 2 minus of minus plus 2 sine theta by 2. YCM equal to 2 r sine theta by 2 upon theta by 2 minus theta by 2. Theta by 2, it is only theta, right? That is now giving us the y coordinate of center of mass. Okay. And coming to x coordinate, it is 0. Center of mass will be on the line of symmetry. In this case, that line of symmetry is nothing but y axis. That's why having only y coordinate. It is a 2r sine theta by 2 by theta. For example, if we are given half circle, if we are given half circle, see for a half circle, this total angle is 180. That means theta value how much? Theta value is a pi. Okay. Theta pi means substitute here sine pi by 2. That is 1. And this is a pi. So this is a pi, right? That means for semicircle, for semicircular circle, y coordinate of center of mass is 2r upon pi. Okay. For semicircle, y coordinate of center of mass is 2r by pi. Right. Let us see next one. Next one is semicircular plate. See how to calculate. Right. It is now semicircular plate. So this is now semicircular plate. See how to find center of mass for this one. Center of mass for this one. This semicircular plate can be taken as a combination of semicircular wires. This is taken as combination of semicircular wires. See how we are taking. So it is again, if you imagine line of symmetry, center of mass will be on the line of symmetry. Okay. If you call this as y-axis, it will be on y-axis. Okay. Now let us consider one ring. Sorry, taking a half ring. Consider a half ring. Take its width equal to, so I'm taking a ring of radius r. How much? It is small r. Okay. This width equal to, we can see that width equal to dr. It is dr. Now we can see for this semicircular wire, center of mass will be at a distance 2r by pi. Just now we have learned, right? YCM for semicircular wire. It is 2r by pi from the base. Okay. So for this semicircular wire, center of mass is at this point. Distance equal to 2r by pi. That means we can replace this entire semicircular wire with a point mass and placing that at its center of mass. Okay. We are replacing this entire semicircular wire with a point mass, placing at its center. So just like a point mass. Then see what we can do here. YCM equal to integral y dm upon integral dm. Okay. So here what we are doing is y value. Y value will be 2r by pi in the place of dm. Since it is now semicircular plate, means two-dimensional body, so we are focusing dm equal to sigma into the corresponding area called as ds. Okay. So sigma is mass per unit area ds. Now you should be very careful here. We are finding mass of, see this part, mass of this part of the wire. Okay. And you can see its mass equal to, means corresponding area equal to. If you make it straight, if you make it straight, it becomes a rectangle. You can see here, it becomes a rectangle. A rectangle of length how much? Length equal to pi r. Breadth how much? It is dr. So area equal to how much? Pi r into dr. Okay, that is now dm. I hope you got clarity how we are finding mass of this part of the wire. Okay. So sigma pi r dr upon integration of dm, again sigma pi r dr. Like this, we have to consider half rings from r equal to 0 to capital R. Okay. So here see constants, the calculation part. We can cancel constants sigma. Next, pi. See, here we cannot cancel R. Reason is R is not a constant. Okay. Now take calculation part. YCM is equal to what else left? I can take 2 by pi outside. Remaining is R square. I am taking 2 by pi outside. Remaining is now integration of r square dr. See carefully. Upon integration of r dr. So 2 upon pi. It becomes r cube by 3. And this is r square by 2. Now take limits. Taking limits. First of all, here any 0 to r, right? R cube, this is r square. Remaining is r. 2 to so 4. 4r by 3 pi. Okay. That is now y coordinate of center of mass. What about x coordinate? It is 0. Because we have discussed that center of mass will be on the line of symmetry. Okay. Right. Let us see next one. So next one is hemispherical shell. Right. Let us see how to make calculation. Hemispherical shell. So first make a diagram. This is now hemispherical shell. And again here we can say center of mass will be on the line of symmetry. This is now base. I'm taking midpoint. Just imagine a line of symmetry. Let us call this as y-axis. Okay. Now center of mass will be on this line of symmetry. So first we have to focus how to consider elements. Okay. If you observe, if you cut it into slices like this, means parallel to base. If you cut parallel to base, we get rings, right? So it is now combination of rings. Is a pointer. It is combination of rings. Then see what we can do. For each ring, center of mass will be at its center. So first I am taking a ring. See how we take element now. With a line of symmetry. Take at some angle alpha. Take a small change from there. That is now d alpha. If you rotate this vector, this forms one ring, right? I will show you here. This is now that ring. This is now that ring. Okay. Now for this ring, center of mass will be at its center. Then see what I can do here. YCM equal to integration of y dm upon integration of dm, right? So coming to here, y value. Since radius equal to r, here that y value equal to r cos alpha, right? So y value, I will write here y value, y equal to r cos alpha, right? Next dm. See how to get dm. Remember, this is a three-dimensional body, but mass is not in the volume. Even though it is a three-dimensional body, mass is not in the volume. Therefore, here we are taking mass per unit area. Okay, that is sigma. So it is equal to sigma into, see what is now corresponding area? Area of this circle. Okay. So for the circle, length will be 2 pi r cos alpha, that is length, right? And its breadth will be, it is equal to r d alpha, okay, into r d alpha, okay, sigma into 2 pi r cos alpha into r d alpha. See here what I'm writing here. I'm writing length into breadth, that is area, okay. So same logic we have taken earlier, right? In first case, while taking that, while taking the semicircular plate, okay. So this is length and this is breadth. Length into breadth, that is area. Area into mass per unit area. This is now dm. Now substitute. Now substitute there. And see while substituting dm, sigma constant, 2 pi constant, right? R and R, right? In the place of dm. That means see what we can cancel directly without substituting there. Sigma constant 2 pi r and r constant. Remaining is only cos alpha d alpha, right? Remaining is only cos alpha d alpha because dm anyhow gets a cancel there. So I'm taking directly here without writing all these things once again. Directly integration of, in the place of y, r cos alpha in the place of y. Coming to dm, I am writing directly cos alpha d alpha because remaining is 2 pi r square constant. Anyhow cancels, dm cancels. So directly I am writing here. Wait, here. I think I made one mistake. That is in the place of, wait. All right, this is not a correct one. See where we are done mistake. Y is anyhow r cos alpha. That is okay. But coming to radius of the circle is r sine alpha. It is r sine alpha. Okay, right. So r cos alpha. I am writing directly sine alpha d alpha. Sine alpha d alpha. Okay, upon integration of sine alpha d alpha. Okay, right. Like this, we have to consider from 0 to 90. If you take a 0 to 90, we get all rings. Okay. So you should be very careful while taking limits. We are taking 0 to 90. Then we get all rings. So here, see what we can do. Take R outside, sin alpha, cos alpha. Multiply and divide with 2. So what happens is, it becomes now sin 2 alpha. Okay. Sin 2 alpha d alpha upon sin alpha d alpha. Okay. Now you can see the remaining calculation part. R by 2. Integration of sin 2 alpha d alpha. It becomes minus cos 2 alpha by 2 upon minus cos alpha. Anyhow, minus gets cancelled. Remaining, take limits 0 to 90. See, when I'm taking here 90 means pi by 2. See what we get? Cos 2 alpha becomes a cos pi, right? Minus 1. Next, r by 2 limits. First cos pi, that is minus 1, minus next 0, cos 0 is 1, minus 2 upon coming to here cos 90, 0, minus cos 0, 1. This is minus 2, right? This is minus 2 and this is minus 1. Minus 2 minus 1. It is 2. See once the calculation part. Anything we are missing here? We have multiplied and divide with 2. So r by 2 sin 2 alpha. Right. Here we have taken 2 outside, right? That we have not taken. It becomes 4. R by 4. Okay. So this is minus 2. This is minus 1. Total is 2. So this becomes now r by 2. Okay. This is r by 4. Because we have taken 2 outside, r by 4. So final answer is r by 2. That means center of mass is at a height from the base r by 2. Or we can say from here also r by 2 because it is a half, right? R by 2. So like this, we can calculate center of mass. And for remaining, we can discuss in the next lecture.